Hello and welcome to this Formlabs webinar. This is a shortened version of the original broadcast. If you'd like to view the content in full, please click on the link below.
Hello everyone, and welcome to today's webinar, Vital Auto, how a premier industrial design studio leverages SLA and SLS tools. My name is Maria Ma, the Marketing Campaign Coordinator for Engineering.com, and we're joined by our speaker for today. Welcome, Adam Harrigan, Channel EMEA Sales Engineer for Formlabs. Adam's main goal is to make your 3D printing dreams a reality.
So a bit about Formlabs. We really do create reliable, accessible 3D printers aimed at professionals. What does this mean to be reliable? One is that you can print around the clock without worrying about the machine going down. We've had many years in the field, over 10 years now, with creating these devices. Accessible meaning that it's the right price point, that you can get it into your office or into your environment without breaking the bank as such. And also accessible in the sense that you do not really need to take a 5-month or 5-week-long training course to figure these devices out. Really, it's spending time for you. It's going to be working on your CAD and not figuring out the 3D printer. Just be a couple of training sessions to get you up and running. And really, this is why we say professionals, because we have many different resins designed at many different worlds where professionals can use them. Our mission at Formlabs is to expand access to digital fabrication tools so anyone can make anything. So whether you're a designer, whether you're an engineer, whether you're a medical professional, whether you're just coming out of university, or whether you're in some kind of maker space. This is our whole ambition here, is to take very expensive products, make them very, very easy to use, but also make them relatively low cost, so you can get them in site with relatively fast. Moving swiftly along, I'd like to bring the focus to Vital Auto. There's a bit of eye candy for us to look at, where you can see a beautiful car. Most of this car would have been 3D printed. So that's something that the first takeaway is that most people, when they see this kind of stuff, they think, oh, that can never be 3D printed. These guys are absolute magicians of 3D printing, but they're not only just 3D printing wizards, they're also, really able to produce amazing designs, first off, which is the heart of it, right? Like a 3D printer can only do as well as the design. And then the other part of their puzzle is finishing these parts to make them look indistinguishable from an injection molded part. I've been fortunate enough to work with these guys, bringing some of their designs to reality and giving consultation on how to make things work with our devices. Here's another example of some of the parts they do. So this is a scale model actually produced in collaboration with Rolls-Royce, and this is actually hanging in a museum in the UK. So to step back a bit about who they are, so Vital Auto are an industrial design and development company. They are specialists in niche car development or custom car development. So if you think about the likes of some of these names I'm going to show you in a second, they're clients, but think about the likes of a huge OEM. Obviously, they don't have the time or the time really to wait for a mold to be generated, to be machined. This can take weeks, months, costs a lot of money, obviously, and there's no point in creating a mold if you're only going to mold 3 parts out of it for 3 very custom cars. This is why 3D printing has been fundamental to Vital Auto. So again, like it says here in the slide, to be able to turn around and create very complex parts in the matter of weeks as opposed to months, or sometimes days as opposed to months. They use the Form 3L for typically surface finishes that are Class A surface finishes. They can create very, very complex structures, as you will know from our Formlabs products. This is why we're super proud of LFS, which opens up a great new form of 3D printing where we can create very, very beautiful designs with low force stereolithography. And as you can see on the slide, that the Fuse 1 would have been used for more robust parts, complex geometries. They want to be able to build them directly on the Fuse 1. They were already outsourcing a lot of SLS parts. When the Fuse 1 came to market, they were one of the first in the queue, and they've been very, very successful with it. Some of the parts of, that's been really great for us to hear is that when they show their customers the Fuse fleet or the 3L fleet, they're really intrigued by how these devices look and how they function, and they're really intrigued that such a small device can create such high quality and complex geometries with beautiful surface finish, which is typically rare for an SLS machine. So typically with SLS, you guys would have heard of things like orange bark or birch bark or orange peel or these other words where we have a very difficult surface roughness due to how we're cooling down in between layers or due to how it was placed in the build volume. For us, we're super proud that our surface finish creates really, really nice, beautiful parts because we build our armor around our parts, and they've really benefited from this in this very aesthetic-based and also rigorous base of building cars. So as I mentioned, when we were talking about their clients, I told you I'd talk to you about later on. So imagine the likes of McLaren or Land Rover or Jaguar would come to them and say, hey, we need a car produced in a matter of months. Here is some initial designs or drawings. Can you help us? And they would even do things like, build in different parts of a virtual reality. So you sit inside a car and you're touching the actual interface, but you're actually seeing something completely different with a virtual reality headset. The other stuff you can see here is real, so everything other than the central slide here, this is all real 3D printed parts that are, parts of custom cars that we go to show or, live in the OEM. And you can see the beautiful surface finishes they're able to get and very complex geometries. So what are they actually using right now? They started with a Form 2, which is super interesting for us. When we first met them a couple of years back now, they were using a Form 2, and they were typically not really power using with that Form 2. They were really using the majority of time they were using FDM. But we were able to work with them to kind of talk to them about materials and really open up the world of Formlabs and open up to which type of materials to use at which type of the product iteration or which material to use which application. So they went to using 3 Form 3Ls, which was great for them. As you can imagine, automotive, you saw an airplane, big parts, so they wanted large format. And then when Fuse 1 came out, they were super excited and they scaled from using 1 fuse in the space of, let's say, January, to then about 6 months later, upgrading to about 5 fuses. And now they're using 5 fuses with hopes of getting a few more as we develop new materials. And for our existing materials like glass filled, has been super interesting for them. I'll talk about that later on. So let's have a quick look at some of the parts they actually produce in-house and why they choose those types of materials. So here is an air vent. They use this really because they wanted to conceal, the proprietary. They wanted to be able to first produce this super fast. So they used draft on the 3L. So they could produce this part probably in a matter of hours. And then they moved to a rigid 4K in this case to make a production ready part. So this is the actual part that would have went on to the show car or the concept car. One of the things they told us about rigid that they really loved, they were using white. White is very easy to paint, as you're all aware of, naturally. However, white resin, as we mentioned before, it's great for a look and feel model. However, when it comes to machining that or screwing it or this kind of stuff, you will notice that it becomes brittle or it can naturally be easier to break than a rigid resin would be. And they noticed that when they were passing the resin down the line, so when they were kind of going from print stage to now painting stage, as I mentioned, that's naturally a big part of how they make these things beautiful is, painting them and using that skill set that they have years of experience. So their model makers would have been breaking those white parts and being very heavy-handed with them. And they noticed that when they switched to rigid, they were much easier to machine, much less likely to break. So that was one of the great takeaways from these guys. Another great part that they've shown us, this is a huge cost saving for them. Traditionally, this kind of part would have had to be injection molded. However, this part would have been a really complex mold, taken a long time to formulate. And as I mentioned in the beginning, it doesn't really make sense to produce a mold when you're only going to produce 3 or 4 of these parts. So they moved to the Fuse 1 for printing this, particularly nylon 12, because of the really attractive refresh rate, and also down to the fine details that they can achieve. So you can see some of these walls here, less than 1 millimeter as semi-supported or unsupported walls, and they found this really, really useful. As you can see, this is a part that's just come off the printer. it hasn't even had any media blasting that you can see from some of these little cavities with built up powder. This is exactly how it would look directly out of the fuse sift. Another cool little part where they're able to use both SLS and SLA. As I mentioned, they have two different print farms and they're using most of the time these materials in comparison with each other. Sometimes they're in a world where they need to see something fast, so they'll use a draft, and then they'll move later on into a functional part which has some load on it, and they'll move that to a nylon 12, which naturally has better load compatibilities or capabilities. This is a great example of using three different resins, however. So they would have started with a black, and then they would have started with a tough 2000 for the outer shell. And then they started to play around with using optically transparent parts. So they moved to clear, which naturally would let the light through. Clear can be polished as well to become optically clear, which you can use as a type of lens. We have some information about that on our blogs if you're interested. And this is what the part actually looks like when it's applied into the car with some electronics. They do have mechatronics capabilities in-house as well, so they can literally do everything under one roof. So this is a great part of, again, where you really wouldn't know these were 3D printed parts by the end of it. So again, optical clarity with our clear printed resins. Another part that I was really, really happy to see, it may look pretty small and insignificant, but the ability to print elastonomers with a nice tear strength is very difficult in the 3D printing world, and we've achieved that with flexible ATA. So these are door seals. You imagine the idea of taking an elastomer and pour molding this, or traditionally molding this, again, would take a long time. You have to build a mold. These are complex seals as well because they're overlapping. So in this world, they would have just printed this directly on the Form 3L. And actually they colored this black by using some pigment from our pigment kit, and they took our flexible ATA, which is a more of an opaque kind of transparent color to it, and they use flex ATA with a bit of pigment inside. We would work together to find the right formulation of pigment. So bear in mind, we wouldn't recommend this without talking to one of our team first to walk you through adding pigment to those resins. So typically these parts would have been extruded, as it says, requiring pretty heavy tooling. So they would either have to take a lot of silicone or a lot of rubber and cut them down, which would have been quite wasteful if it's only a one-time part they need. And this is a great example of where they were able to slightly change their business model, which we'll hear from Anthony talk about later on. So instead of just printing for the custom cars they're creating, when their customers, OEMs, see this material and learn about these applications, or learn that we can 3D print these elastomers, it's normally a light bulb moment where they think, actually, we could do with 100 of these small parts that we just need for this particular type of it may be even a manufacturing tool. Maybe it's not even going onto a car. And that's been a really nice thing to see, is that these OEMs are also using them not just for a particular type of show car, but also as a kind of a service where they would ask for 100 of these parts or 100 of that part.
Thank you for tuning into this webinar preview from Formlabs. To view the content in full, please click on the link below. Alternatively, if you'd like to get more information on our products and services, then please visit our website.